Last week, a security scanner, a signed provenance attestation, and a Red Hat engineer walked into a bar, and while they were comparing compliance badges, a worm crawled in through the build system and stole everybody's wallet. It's called miasma, and it's currently self-replicating through the NPM registry using a file your security tooling has never once looked at. If you, or any package you depend on, ran npm install in the last 2 weeks, its grubby little tentacles may already be in your AWS keys, your GitHub secrets, and yes, even your 1Password vault. That's a problem because the average JavaScript project depends on 1,200 packages maintained by anonymous burnouts, and you've personally vetted 0 of them. It's June 12th, 2026, and you're watching the Code Report. Our story starts on June 1st when somebody compromised a Red Hat employee's GitHub account. The attacker pushed malicious orphan commits to 3 Red Hat Insights repositories, sailing straight past code review because apparently code review was a suggestion. Those commits triggered a release workflow that runs on any branch push, which politely requested an OIDC token and published 32 poisoned packages under the official Red Hat Cloud Services namespace. Together, those packages average about 80,000 downloads a week, and every single one shipped with valid signed provenance. That green checkmark you trust? The worm has it too. Supply chain security theater at its absolute finest. But Wave 2 is where it gets worse. On June 3rd, 57 more packages got hit, including the VAPI AI Server SDK with another 86,000 weekly downloads. These didn't use pre-install scripts, which is the one thing every security scanner on Earth actually watches. They used binding.gip. Binding.gip is the build config for native modules. If that file exists in a package, npm automatically invokes no gip, no lifecycle scripts required, no opt-in, nothing. This is the entire payload, 157 bytes. That little bang parent is GYP's command expansion syntax, and it executes shell commands during the configure phase. So Node runs the malware, pipes the evidence to dev null, and prints a clean little stub file like nothing ever happened. Your package JSON? Spotless. There is literally nothing for a script-focused scanner to flag. Now the payload itself is a work of art, a 4.5 megabyte loader wrapped in a ROT14 Caesar cipher inside AES-128 encryption. It then downloads its own standalone bun runtime and runs the actual stealer under bun instead of Node, specifically to dodge process monitoring. Yes, the malware migrated to bun before your team did. From there, it vacuums up AWS keys, GCP service accounts, Azure tokens, Vault tokens, Kubernetes credentials, and your password manager. It even reads GitHub Actions runner memory directly, which walks straight past secret masking. And my personal favorite, it commits backdoor hooks into your .claude and .cursor folders, so your AI coding agent re-executes the payload every time you open the project. Your pair programmer is now a sleeper agent. Then it spreads. The worm looks up every other package its victim maintains, injects itself into each one, and republishes them with forged SigStore attestations, naturally. It also ported itself to Ruby gems through xtconf.rb because diversification is important in this economy. If Shehalud sounds familiar, that's because this is the same worm family that's been ravaging NPM since late 2025, courtesy of a group called Team PCP. The new variant swapped its Dune references for Greek mythology and stamps its repos with the label Miasma, the spreading blight, a name that goes unreasonably hard for a credential stealer. So what do you actually do? First, and this order matters, remove the persistence hooks before you rotate credentials. Otherwise, the backdoor just steals the new ones while you pat yourself on the back. Then nuke Node modules, reinstall with ignore scripts, pin your versions with a lock file, and rotate every token your CI has ever breathed on. And maybe, just maybe, stop auto-updating to packages that were published 14 seconds ago. Zoom out, and the pattern is grim. Attackers moved from install scripts to AI agent hooks to build files nobody monitors, each step one layer deeper than the tooling can see. And signed provenance didn't save anyone because the attacker just signed the malware with your own pipeline. A signature proves where code came from, not that it isn't evil. As always, remember the S in NPM stands for security. This has been the Code Report. Thanks for watching, and I will see you in the next one.